Alrighty, sitting here after a nice Bears win, a little sloppy at times, but good win over the Steelers. So, last video you looked at angles being congruent or supplementary if we knew that lines were parallel. Okay, again, in something like this where we have a transversal and two lines. Today, we're actually going to go backwards from that. So again, yesterday was if two or more parallel lines were cut by a transversal, then we knew that those those angles had certain relationships. Okay, so either they were congruent to each other or they were supplementary. They added up to 180. It was one or the other. So today we're actually going to do the converse of that. And thinking back to Unit 2, converse means we flip the hypothesis and conclusion. So what we're going to say today is that if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If same side exterior angles are supplementary, then the lines are parallel. Again, notice that supplementary occurs with same side both times. Okay, so that's a little way of remembering it. Lastly, if two lines are perpendicular to the same line, then the lines are parallel. Meaning if both lines are creating 90-degree angles, then they have to be parallel to each other because they're going at the same exact angle. So if this is 90 degrees, this is 90 degrees, then those lines have to be parallel. Okay, so again, going backwards from what we did yesterday. So if we look at a couple of examples, we have to do that. So what this is saying is if angle 6 is congruent to angle 8, so we know how to mark that. If that's true, then we know that A and B are parallel because we know that corresponding angles are congruent. Okay? If we looked, I'll leave that actually that color. If we looked at angle 2 and 7 and said that those are congruent, again, we know that A and B are parallel because alternate interior angles are congruent. Okay? Lastly, if we see that angle 1 is congruent to angle 8, okay, again, these are things that you should know as soon as you see them now. If angle 1 is congruent to angle 8, that means that we have alternate exterior angles, and those are always congruent. Okay, again, here's your transversal. So it's either same side of it or alternating over, and then it's either inside or outside those two blue lines in this case. Okay, if we look at another one, find the value of x so that m is parallel to n. Okay, well, look at where these two angles are located. First, determine what your transversal is. There it is. You know that these are your two other lines, so decide what kind of angles are those? What's the relationship between the two? Well, they're on the same side of the transversal and they're inside the line. So they're same side interior, and what we know about those is those are supplementary. Okay, again, look back up to this at the top if you need to remember that. But same side are always going to be supplementary. So if we know that's true, we know that we have to have those two angles combining to create 180 degrees. So we get 8x minus 4 equals 180. Add 4 to both sides. So we have 8x equals 184, which gives us 23. So again, if x is 23, if we plug that back in, we would find that those two angles added up to 180 degrees. If we look at another one of these, if we see that 1 and 2 are congruent, okay, so let's mark that. 3 and 4 are congruent. Which lines are parallel? Okay, so there could be more than one. Again, figure out where your transversals are. Okay, so if 1 and 2 are congruent to each other, we know we have alternate interior angles over that transversal. Okay, so they're alternating over it. They're in between these two lines. So we know that those two lines have to be parallel to each other because we have alternate interior angles are congruent. Okay. Again, we also know that, I'm going to get rid of all this so you guys can see a little bit easier. We know that angle 3 and 4 are congruent. So again, you have to have a road, if you want to think of it like that, between these two angles. So our road in this case is that angle there. Okay, that's our transversal. We know then that these two angles, or these two lines rather, have to be our lines, our parallel lines in this case. So we know that both of these angles are in the bottom right of the kind of the 4 square locations. So we know if they're both in the bottom right, then they have to be corresponding. Corresponding angles, if they're congruent, then we have parallel lines. So we would say that M is parallel to N because corresponding angles are congruent. Okay, so again, locate the transversal, then decide what kind of relationship you have. Okay, if we look at example 4, we have angle 1 and 7. Okay, so those are congruent. Now, we have a transversal, and it's right here. Okay, you should know that 1 and 7 are vertical angles. Nowhere in there does it say anything about vertical angles having anything to do with those two lines. We're trying to show that J and K are parallel, but we only have angles we're talking about in this location. K is not involved at all, so we can't say that those two angles are congruent. So we would say no, vertical angles don't prove lines parallel. Okay. If we look at the second one, angle 3 is 2x plus 15. Angle 7, let me get rid of that. Angle 7 is 3x plus 15, and x is 40. Okay, so we're going to plug in x. We're going to use a substitution property, plug in x. If those two lines are going to be parallel, again, here's our transversal between those two angles. We want these two angles to be congruent, because then we'd have alternate interior angles. So we're going for those two angles to be the same thing. Let's see what happens. So if we plug in 40 here, 3 times 40 is going to give us 120, plus 15 is 135 degrees. So we need angle 3 to be the same thing. Okay, 2 times 40 plus 15 is 80, plus 15 is going to give you 95 degrees. Okay, so angle 3 is 95, angle 7 is 135, so no, those angles are not congruent. Okay. I'd like you guys to try example 5. Again, I'm going to give you a hint on these. Split up these angles. Okay. Split up all where you see those little crooks sticking out. And then work from the top down till you get to angle 1. And then once you get the top half of angle 1, go from the bottom up, get the bottom half of angle 1 and add them up. So again, I'd like you guys to try example 5, have this one down in your notes, work from the top down, then the bottom up, come up with your angle 1. See if you can work through that one, look at your notes from yesterday if you need to. We are going to go over example 6 tomorrow. So example 6 you can look at, but we are going to go over this one tomorrow because that's a proof. Proofs will start more next unit, but this is a little baby proof to get us started with them. We need to be able to do these. You'll see a lot of them, but we'll go over this one together so I can tell you exactly what I'm looking for in a proof. That's all for now. Bears win.